In chapter 5, we are going to talk about sampling distributions. So in chapter 4, we had discussed finding probabilities mainly with discrete random variables. So in chapters 5, and then we're going to continue on in chapters 6 and 7, we're going to talk about continuous random variables and how you find probabilities and then more things you can do with those. So just kind of review when we talked about continuous random variables in chapter 4 and then also the normal distribution back in chapter 1. A continuous random variable is a variable that can take on any value within a specified domain. So every interval within the domain has a probability associated with it. So that's the probability of something being less than, greater than, between, greater than or equal to, all of that stuff. So we typically will use a continuous random variable to describe a population. So, and it does, the only way you can really represent that is with a bell curve. And then the area under that curve at any given interval represents the probability that a particular value lies in that interval. So just kind of review. So if I have some arbitrary x variable and some arbitrary value that I want to be within that, if I want to find the probability that x is less than some value, so I have my normal curve, and then I have my x sub a, my probability is everything below that value. You can also be between two x values. So my first one and my second one. And then between them is the area in the middle. And then lastly, if you want to be above some specific value, you have your area above, which is what we had discussed earlier. So when we are talking about finding probability with normal random variables, we want to make sure that we kind of identify our distribution and then the values of interest. So we want to write our probability statement, basically, when we figure out what am I trying to find. You're then going to perform your calculations. So we do want to make sure we show our work, whether that means changing to z-scores and drawing the curve or identifying what we plugged into the calculator. You want to make sure you show your work. And then lastly, you want to answer the question of interest. All right, so let's look at an example. So the heights of young women closely follow the normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. So this is a distribution for a large set of data, and we want to choose one woman at random. And we want to find the probability that the chosen woman is greater than 65 inches tall. So we're trying to find the probability that x is greater than 25. So one of our options is to go ahead and calculate our z-score. So just to kind of refresh, your z-score is your x value, 25, minus your mean. I don't know why I wrote 25, 65. 65 minus the mean, 64, over our standard deviation of 2.7. So 65 minus 64 is 1. 1 divided by 2.7 is going to give us a z-score of 0.37. So now I'm going to use normal CDF. And my lower bound, because I want to be greater than, is going to be 0.37. My upper bound is going to be my 1E99. And because I calculated my z-score, my mean is 0 and my standard deviation is 1. So we go to second vars, we go to normal CDF. We plug everything in. and we get a probability of 0.3557. So that's option 1. Option 2 also involves normal CDF, but it involves using the values we were given. So if I want to be greater than 65, my lower bound is 65. My upper bound is the 1E99. I'm going to plug in my mean of 64 and my standard deviation of 2.7. Now, this method is technically more accurate if your z-score is not an exact value. So like when we calculated our z-score, it wasn't exactly 0.37. So this method might give us just a slightly more accurate probability, which gives us 0.3556. So not really a whole lot different. You end up with 0.3556 instead. So pretty much the exact same answer. I would accept either, again, as long as you have your work telling me what you plugged into the calculator. Otherwise, I might associate it with a rounding error if you had calculated the z-score. For our next example, we want to find the probability that the chosen woman is less than 63 inches tall. So we want to find the probability that x is less than 63. So again, I'm going to do the first method, which is calculating my z-score, 63 minus 64 over 2.7. So in this case, 63 minus 64 is -1. So I'm going to get negative 0.37. And as we kind of already discussed previously, the area above and below the same z-score, but one is positive and one negative, is going to result in the same probability. But we'll go ahead and do the calculator just to make sure. So normal CDF, this time my lower bound is -1E99 because I want to be less than. My upper bound is the negative 0.37. My mean is 0. My standard deviation is 1. And I'm going to get the exact same probability, 0.3557. I'm not going to check with the other method. You get the exact same thing. If I did normal CDF with my lower bound being the -1E99, but my upper bound being 63, mean of 64, standard deviation of 2.7, I'm going to get 0.3556 as well. I'm not going to check it, but you can. Then for our last example, the probability that the chosen woman is between 68 and 70 inches tall. So that's the probability that 68 is less than x is less than 70. So my first option is to calculate both z-scores. So 68 minus 64 over 2.7. So we're going to have 4 divided by 2.7, which is 1.48. My second z-score, 70 minus 64 over 2.7. It's going to be 6 divided by 2.7. And we get 2.22. So we have normal CDF. My lower bound is the smaller z-score, 1.48. My upper bound is the bigger one, 2.22. Mean of 0, standard deviation of 1. And we're going to get 0.0562. Okay. And again, might be slightly more accurate to use the actual values, so normal CDF with the lower bound of 68, upper bound of 70, mean of 64, standard deviation of 2.7. And we're going to get 0.0561. So again, almost exactly the same. Very, very little difference. As you can see, the difference usually lies in the 4th decimal place instead of the 3rd. So if you round to 3 decimal places, you'd have the exact same answer no matter which method you used. But if you round 4, that's where you might start to get a different answer. All right, so next let's talk about combining normal random variables. So Mrs. Belcher liked sugar in her iced tea. From experience, she needs between 8.5 and 9 grams of sugar in her iced tea to make the drink taste just right. While making her iced tea this afternoon, she added 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What is the probability that Mrs. Belcher's iced tea tastes just right? So we want to find the probability that we are between 8.5 and 9 grams of sugar. All right, so X is going to represent our sugar here. So that's 1 packet of sugar we know contains 2.17 grams of sugar with a standard deviation of 0.08. So we need to figure out our mean and standard deviation for 4 packets of sugar. So our mean for 4 packets of sugar, we can just do 4 times 2.17. That one's pretty straightforward. And we're going to get 8.68. Standard deviation is going to be slightly different. I have to do the square root of 4 times 0.08 squared. So I have to square my standard deviation and multiply it by 4, since I'm talking about 4 packets, and then I have to take the square root of it. So 4 times 0.08 squared is 0.0256. And then you take the square root and you get a standard deviation of 0.16. So now I have the mean and standard deviation for 4 packets of sugar instead of just 1. So now I can go ahead and do exactly like we did in our previous examples. I can find my 2 z-scores. So my first z-score is going to be 8.5 minus 8.68 over 0.16. Which is going to be negative 1.125. My second z-score, we're going to do 9 minus 8.68 over 0.16. And we're going to get 2. So I'm going to do normal CDF. My lower bound is going to be negative 1.125. My upper bound is going to be 2, mean of 0, standard deviation of 1. And we're going to get 0.847. It actually is 0.84696, but that 9 makes it become a 7. So then I'm also going to now start writing a sentence. So the probability her iced tea tastes just right is 0.847. So pretty good chance, pretty high probability, not too terrible. All right, last example. The diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inches. For the lid to fit on a cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. What is the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? All right, so a couple of things here. We have a little bit of it's a little bit more of a confusing distribution. So the size of the difference, L minus C, between the lid diameter and the cup diameter, would be L minus C, where L is greater than C, but not more than 0.06. So I'm going to define that L minus C as F, like if it fits. So I'm trying to find the probability that the difference is between 0 and 0.06. So that's what my probability is. So they could be the same. It could be up to 0.06 more inches. So we have to calculate our mean and our standard deviation. So the mean for our fit, because F is L minus C, I can go ahead and subtract them. So 3.98 minus 3.96. So that's going to give us a mean of 0.02. For the standard deviation, not as straightforward. So I have to square each of the standard deviations and add them together. So I'm going to do 0.02 squared plus 0.01 squared, and then I'm going to take the square root. So 0.02 squared plus 0.01 squared is going to give us 0.0005. Which, when I take the square root of, we're going to get a standard deviation of roughly 0.022. So now I can calculate my two z-scores. So my first z-score, we're going to do 0 minus 0.02 over 0.022. So negative 0.02 divided by 0.022. And we're going to get negative 0.91. Our second z-score, we're going to do 0.06 minus 0.02 over 0.022. So 0.04 divided by 0.022, and we get 1.82. So we'll do normal CDF. Our lower bound is the negative 0.91, upper bound of 1.82, mean of 0, standard deviation of 1. And we're going to get 0.7842. So that tells me that the probability a randomly selected lid and cup fit is 0.7842. So not a super great probability. I mean, it's only like 78% chance, but it's not a terrible probability. It's not like it's 20% chance. So let me know if you have any questions just reviewing the normal distribution, calculating probabilities, or in this last page, combining normal distributions.